Welcome to Thursday's lecture for Lesson 2 on Technology and Mapping. Today we're going to be talking a little bit about GPS. So going back to Monday's illustration of using the right tools, think about how maps were made in ancient times. Now, originally you had people just kind of surveying the land by eye, writing down features, trying to memorize where coastlines were and how they moved. And then as technology advanced a little bit, you had map makers for centuries using kind of rudimentary instruments. They used a compass, which we know we can use to find direction. Based on the Earth's magnetic field, let us know which direction we're in. They used telescopes, which could definitely not even see as far as what we can see now, but then as they advanced, then maps and map technology really advanced. And then they used an instrument called a sextant. This is a navigation tool, and it was used to measure the angle between objects that could be observed, and really was used a lot for navigating through the stars. So most ships would be equipped with them, but map makers really made a lot of use out of them. Today, map makers use computers and data from satellites and have a lot more advanced technology. And one of the important resources that they use, in fact, now it's very prevalent, is GPS, or Global Positioning System. So this is actually a group of satellites that's used just for navigation. So I'll show you some pictures here. You actually have a number of satellites. I've read that there's as many as 32 that are used. 24 to 27 are used regularly, and the others are used for backup. And these are used to send signals to devices on Earth, and then the signals are returned, and these relayed signals are used to calculate a position. So it has to do with distance to a satellite based on the average time of the signal. So the devices can be all kinds of different things. You can have a GPS on your phone, which most people have. You can have a separate GPS unit for your car, all different things. And they can be, huge, they can be small. I actually have a GPS in my watch now. So there's a lot of different ways that we can use GPS and that we do use GPS. So here's how it works, though, because you may be wondering, well, so what? Is there a satellite and that satellite just figures out where we are? Well, as I mentioned, it's more than one. In fact, you need to get a signal from at least 3 satellites. And so that's why at any time, as we showed in this picture, you're getting signal from at least 3 in order to figure out exactly where you are. So this is called triangulation. So what happens is information from one satellite tells the GPS receiver that it's somewhere in a sphere surrounded by satellite 1. So when you get that first signal from the satellite, it just can tell you it's within that radius. And suppose that that distance is 20,000 kilometers. So this limits the possible location on Earth to somewhere within the sphere of 20,000 kilometers. So it's not going to be anywhere in that sphere because that satellite is out in space. So it then limits it to just the radius or a circle on Earth's surface that is within that sphere. So then the next receiver measures the distance to a second satellite. Now suppose this distance is calculated to be 21,000 kilometers. So the location of the receiver is somewhere within the area where the 2 spheres intersect. So you can see satellite 1 and satellite 2, we got kind of like a Venn diagram. It's going to be somewhere where those 2 come together. Now, finally, the distance to a third satellite is calculated. So using this information, the location of the receiver can be narrowed even further. So by adding a third sphere, so remember we're talking three-dimensional, so by adding a third sphere, the location calculated is calculated down to one of 2 points. So I know that in our Venn diagram here it's 1 point, but that's two-dimensional down to one-dimensional. So think bigger, think 3 dimensions, and it's narrowing it down to 2 points. So a line, basically a plane, so it's somewhere in there, and one of those points is in space and the other is on Earth's surface. So now we can tell exactly where it is because you're not in space, you're on the surface of the Earth. So information from a fourth satellite can be used to tell elevation above Earth's surface. So if you see the picture there of the globe and the 4 spheres, that's giving you all 3 dimensions. So a pilot or a climber, we don't really rely a lot on elevation while we're driving so much, but other uses of GPS would definitely need elevation. So at any time, though, out of the 24 to 27 that are active, you're actually picking up a signal from quite a few. So if you watch this GIF, you're going back and forth between 7 and 10 satellites that are picking up your signal, and that makes it a lot easier for it to pinpoint. Now, GPS was originally developed for military purposes, but now think about how prevalent it is in our society. It's just continuously available for everybody worldwide. Airplanes, ships, cars have navigational technology built right into them that use GPS. If you're out and you say, hey, I want this restaurant to eat, which this happens to me all the time. Well, I'm out, I say, you know what I really want? I really want Chick-fil-A, or I really want Zaxby's, or I want barbecue. I can go into my phone, I can pull up Google Maps, and I can search for restaurants. And I'm using GPS technology to find my way there. Now, say, because I didn't grow up in this area, I don't really know my way around all that well, and I can end up somewhere. I've done work all over this area. I've been out in Durham, and I've been out to Rocky Mount, and out to Fayetteville, and I say, well, now I need to get home. Well, I use the same technology to find my way back home. So other uses that actually scientists have for GPS, they can track wildlife for scientific data collection. They can detect earthquakes. People use it while they're hiking, biking, and it's definitely used a lot for land surveying. So when you came to the school a few weeks ago, you saw them doing all of that construction outside. Well, they actually go through and they survey the land first to determine different points about it. They use a lot of GPS when making the geologic maps like we looked at yesterday. And so now, though, we've got this amazing technology using 27 different satellites all down in a phone that we carry in our pocket. So think about some of the different ways, these common uses for GPS. Now, GPS technology continues to improve. Back when I was younger, I can remember you couldn't get it on your phone. Smartphones weren't really a thing, and even when we had cell phones, it was just you make calls. So you could buy a very expensive GPS unit that you could install in your car, and now you get a smartphone and it's right there available. So it's getting better and better. So land-based units used in combination with satellites, they're already able to pinpoint somebody's location, place in different places, right down to the centimeter. So I can take out my phone right now, I can pull up Google Maps or whatever, and I can pinpoint where I am down to the room in my house. Now, that's some pretty impressive technology. So future improvements are going to include additional civil channels, projected to improve safety and rescue operations, and eventually could be used to guide self-driven automobiles. So that's some of the things we've seen in the news are these cars that are driving themselves. They're using GPS technology. So now let's talk about GIS. GIS is Geographic Information Systems. Um, these are computerized information systems that are used to store and analyze map data. So they combine data that's collected from all kinds of different maps, many different sources. They use satellites, they use scanners, they use aerial photographs. So think about all the different types of maps that we've talked about. We've talked about the road maps and relief maps, topographic maps. We've talked about the geologic maps. So the GIS is actually taking all of these things, all this data, and something that took months before now takes just hours or minutes, and it compiles all of these things. So map makers use GIS to analyze and organize this data and then create a digital map. If you look at your GPS, you can actually toggle through different types of maps of the area sometimes to see exactly what it looks like. You can go through aerial photography or satellite imagery or topography, whatever you choose. But what they do is they use all of these map layers of the same location. So like what we're seeing here, you've actually got a number of different layers set on top of each other like a cake. So when the map layers are placed on top of each other, you can see through the layers. So they make them transparent so that you can actually tell what you're looking at. And the different layers can show land usage, elevation, roads, streams, lakes, even the type of soil in the ground. So imagine that you're setting up a model for an airplane landing, but you're doing it under terrible weather conditions. The visibility is awful, but you've got access to GIS technology. So you've got a database view that begins the process by assembling information from existing databases. It looks up wind. It looks up the airplane flight. Looks up landing procedures and airport layouts. And then the map view would draw from a set of interactive digital maps that show different features and their relationships to Earth's surface. Then you have model view that would then pull all that information together and run simulations under the different weather conditions. So that's kind of GIS in a nutshell.